The body's humoral, or antibody-mediated immune response, begins in the same manner as its cell-mediated response. But here, the macrophages are joined by lymphocytes, called B cells. The pathogen activates only those B cells with matching receptors. These cells stand ready to enter the battle. Meanwhile, the antigen-presenting macrophages activate those helper T cells with matching receptors. These, in turn, rendezvous with activated B cells. Triggered by this meeting, the helpers release chemicals which spur the selected B cells into rapid reproduction. Some B cells become memory cells, ready to respond to a later invasion by the same pathogen. But most become antibody-producing factories, called plasma cells. Freely circulating in the body, antibodies dock with pathogens. This neutralizes them, or marks them for destruction by other weapons in our immune arsenal. White blood cells, called macrophages, lead the body's cell-mediated immune response by engulfing and digesting foreign invaders. Combining peptide fragments from the invaders with some of its own proteins, the macrophage builds a patchwork of antigen complexes on its surface. When smaller white blood cells called helper T cells encounter the macrophage, those with matching receptors bind to its surface. These helpers then multiply and secrete chemicals which call different cells into battle, especially the cytotoxic or killer T cells. The macrophage, or an infected cell, activates only those cytotoxic cells with receptors that match the antigen complexes. Stimulated by chemicals from the helper T cells, these killer T cells rapidly divide into an army of clones, all designed to fight the specific invader that triggered the response. When killer cells dock with an infected cell, they bombard it with lethal toxins, then move on in search of other targets.
The humoral immune response is initiated by a macrophage, which takes up an antigen, such as a bacterium or virus, and processes it. The macrophage engulfs the antigen in an endocytic vesicle and partially digests it. Class II MHC proteins bind fragments of the antigen and transport them to the cell surface for display. A cell displaying such foreign antigens on its MHC proteins is called an antigen-presenting cell. A helper T cell can bind the displayed antigen if the T cell has surface T cell receptors that correspond to a specific antigenic determinant on the displayed antigen. Once the helper T cell has docked, the antigen-presenting cell releases interleukin-1, a cytokine that activates the helper T cell. The activated T cell now produces a different cytokine, interleukin-2, as well as cell surface receptors for IL-2. IL-2 triggers helper T cells to divide. The daughter cells respond to interleukin-2 by producing a clone of cells identical to the first T cell in genetic makeup and immunologic specificity. Production of this clone completes the activation phase of the humoral immune response. In the effector phase of the humoral immune response, activated helper T cells help B cells develop into antibody-producing plasma cells. Consider a B cell which has encountered the same antigen as was recognized by the original helper T cell. The B cell processes the antigen, and class II MHC proteins transport the pieces for display on the B cell surface. Thus, the B cell becomes an antigen-presenting cell. If an activated helper T cell has the same specificity as the B cell, it can dock with